So we've all been protecting our critical systems using backup. Every night we run a backup to some backup server on some tapes or something. And what that means is the next day when we lose our data, when our server goes down, you then recover last night's data, and most of the time you spend the better part of the day trying to recover the data. So I can't imagine as an IT guy trying to recover an Exchange server in that manner with Exchange being down and still keeping his job. So at BakBone we do two things when it comes to recovering your data. First of all, we actually recover your data in less than 30 seconds. Whether it's Exchange, SQL Server, your file server, we actually get the data back, Exchange is back up, regardless of the size of the data. So you can have multiple terabytes of data. We'll bring Exchange back up and running. And that's some really cool technology behind it, and we'll talk about that in a different podcast. But today we want to talk about how we do it right, how we do it in a consistent manner. So what is application consistent data recovery? Imagine you have a Word document that you're working on and your system crashes. You reboot your system, you will find that there are always two versions. There's a recovered version, there's the version you're working with, and you're not quite sure which is the most current version. So that's what happens when you have inconsistently recovered some data, in this case Word. Now, what happens when this happens to Exchange or your SQL server, your production data, or your large file server? Most products that are protecting your system in a real-time basis do it in this manner. So when the system crashes, they give all the data back to Exchange, and then Exchange has to somehow figure out, I think they use a product called ESC Util, which I believe runs for hours, or you'll have temp files around your system. So let's see how we actually make sure that every recovery point that we give you is a consistent one. Alright, so in this example, we're going to talk about how we do application-aware protection for, say, a simple file system. So this is a very simple file system. This is time going this way is 1 p.m., 2 p.m., 3 p.m. And you're working on a Word document, you're working on a Excel file, your application's creating a number of logs, and there's a version you work on, you close it, and then you work on a version 2, version 1, version 2, and a version 3. In this instance, and a version 1, version 2, version 3 of a sales document, version 1, version at different times. So these are all documents that are being worked on. Now, your system crashes, let's say at 2:20, your system crashes. And so what a normal product, which is not application aware, what that'll do, it'll send all the bits and bytes, all the bytes is captured at this point, and then send it across to the backup server or to the CDP or the replicated server. And when it comes time to recover this, it will give you a small part of version 3, a broken version 3. It'll do okay on the sales.excel file because that's before the crash occurred, that was a consistent version. And it'll give you kind of a half version 3. So you kind of will then have to figure out which ones are the right versions and the wrong versions. It's not a consistent image. What we do with Fast Recover is we actually pick the last consistent versions, so in this case version 2, and version 2 of the 3 of these documents, and give it back to you. So when you get it, you get the versions that work quite right. Now in case of databases, it's slightly different. Now when I say databases, it also includes Exchange, SQL Server, SharePoint, or any other application that's running off a database. And in case of database, we have a log file, we have a control file, and then we have a binary file of the database. And typically with many other solutions, you'll see them taking snapshots. Now snapshots are slightly better than backups, but not entirely different because they're still images that are taken at different points in time. Let's assume you're even taking snapshots, took a snapshot at 1 p.m., so you have a consistent snapshot at this time. Now, your binary files will keep expanding and adding and adding. You will have changes to your binary file. Maybe at 3 o'clock you took another snapshot. Your control file will also have versions as the data changes on your system. And then your log file will also have each and every transaction will go all the way. Just draw these out. So these are all denoting point in times, a single transaction, for example. Now clearly, I'm sure your Exchange server will have a lot more transactions in the 2 hours, but this is your snapshot, and then your binary files and your control files and your log files are changing. Now what happens with the same crash at 2:20 would be something like this. So this is called This is actually called crash consistent, but really there's nothing consistent about it. And you really have a kind of broken binary file, a sliver of control files, and some part of a log file clipped off and given back to Exchange or your SQL Server. If you give this kind of data back to Exchange, what's going to happen is Exchange is going to run ESUtil. It'll try to repair this data because this is not consistent. This is something that even Microsoft says, make sure you have a snapshot. Don't do anything beyond the snapshot. Now, using our on-demand recovery, what that allows us to do is we, at the same instant, for the same crash at 220, we don't need to actually give it the binary data. So we don't give it the binary data, we don't give Exchange back the control files, and we just pick the last consistent log. Let me draw this in red. We just pick the last consistent log that was sent, and the data gets recovered to the last snapshot, and we roll up all the logs. Now we can do it instantly because we have our on-demand recovery technology built in, so there's no need for Exchange to run ESUtil. You get your data back in 30 seconds, and it's all consistent to any point in time. So every second that you recover the data for, it's a consistent data point. So we have this example that works very well for any database out there, and then we have the example for files as well.